Hi, my name is Edgar Saron. On my senior year, I'm trying to be a teacher for math 4th through 8th grade. And this is a project for Math 372 in which we study the algebraic use of stuff in the middle school level. So, the different equations and formulas, as well as how to find patterns. This is the Math Fair project in which we are finding different ways to use math and involve them in the classroom. This project, as you saw, is called How Long Does It Keep Going and Going? The purpose is to have a hands-on experiment for a late elementary and middle school class. This means that it's the way that I came up with this project is to have something to give to the classroom. It's about a week-long project that you can do in a class where you can make it hands-on and you practicing a little bit of math and science at the same time, so involving different subjects. So the problem is that when we buy new batteries, we need to fit our needs. But how do we choose those batteries? Will we do it by the price, or do we do it by performance? Is it because they tell us that it works, or is it because the price is high enough that we think it's going to work? So that's one of the things that started getting me thinking into this project, analyzing the different uses of the batteries and see if the performance really correlates to the price, and if they truly own up to what they say. Now, usually there is a major brands that we go on about and people know about, which are Duracell, Energizer, and Rayovac. Those are the brands that we all trust with our devices, and even though their commercials are a little bit different, we might recognize Duracell getting us with those ethos commercials where they get you through the ER, and they show you how emergency response teams use their batteries to protect the devices or to use their devices because they're reliable and they can save lives. Then you have Energizer with the famous money. It keeps going and going. And last but not least, Rayovac. Even though they don't make as many commercials, every now and then they have one. The most recent was one where they had the race cars going, and each one had the colors of the last three rounds I named. And the one with the Rayovac colors lasted the longest. So, the hypothesis of this project, as you can see, will be if the price of the battery is higher, then that means the performance will be better. So we're going to put this to a test. Now, in the classroom, you can do a little bit of correlation of science. And before you get into this part, you can talk about renewable sources or non-renewable resources. How do we get energy? Different types of energy like gas, electricity, oil. And talk a little bit more about that and show the students that the stuff that we're learning in science class can be applied in math in science, vice versa, history in English, history, math, vice versa. It can be all around. So they can start making a connection and later on where the learning today will affect them and it continue to affect them, and it will just be piling up on them and adding up to it as they go. So make sure that they don't take it for granted and they just don't blow it off. So that will help them realize little by little that what we're doing it has a purpose. So the project, as I have mentioned before in this project, we will compare the different types of batteries and see if the performance and the price has a relationship. So the three major brands, I went out to the closest grocery store, also known as Walmart, and I got a few of these batteries and put them to the test. So the way that I did this project was I grabbed a camera, a Kodak, and I put the batteries in. Now I've separated the batteries by brands in pairs, being really careful that I wouldn't mix the ones that were used with the ones that were new, as well as not mixing brands, to make sure that we don't mess up the data. So what I would do is I will put the batteries in the camera and empty out the SD card, the memory card, and you set it to record. This is where the camera demands the most energy because it's using many things at once. It's using energy for the screen, the LCD display. It's using energy for the lens. It's using energy for the microphone. And putting all these things together is draining the battery. So it really puts the battery to test the performance overall. So I will decide to record. I keep recording until it dies. After it will die, I will take out the batteries, replace with a new pair, and keep on going. So After putting the batteries to the test, I found some peculiar issues that arose. Some of them is that the batteries were getting hot because they were really being tested out. Now, going back to the science part of things, we can see that batteries are built out of chemicals inside, which when they're being run through a current, as they start making the electricity, because there's a chemical reaction going on inside. So that's one thing to keep in mind, that I noticed that because they were getting hot, um, the performance could also be diminished. So therefore, it's not just about how long they last, but how much can they keep their cool. So in the performance here, you can see a chart. Um, the first one that you're gonna see is gonna be Duracell, and Duracell maintains its performance all through. It's not much of a difference. Energizer started a little bit behind Duracell, but later on started passing Duracell and Razorback. It was a little bit slow. It started as a downward motion, but then it picked up its performance. So, in terms of time, you can see that Duracell lasted anywhere from 2 hours and 40 minutes, 2 hours and 31 minutes, and so on and beyond, with an average of 2.59 hours. Energizer goes anywhere from 2.35 to 2.41, even a 2.62 hours average. 2 hours and 35 minutes to 2 hours and 41 minutes. And Razorback goes anywhere from 2 hours and 19 minutes to 2 hours and 29 minutes, even an average of 2.39 hours. If you go back down here and we look at the price, we can see that the most expensive was Duracell at a $4 price for 4 battery pack. The one to follow was Energizer, we're at $2.99 price for a 4 pack of batteries. And last Razorback with $2.97 for a 4 pack. So we put the ratios into to compare, and we continue doing a little bit of math using those algebraic things and trying to predict the outcome of future events, as well as we practice those ratios and correlations in the classroom for middle school level. So the Duracell ratio of the performance of the 2 batteries. So if we put the average time of each battery divided by the price per 2 batteries, we get a ratio where we can compare which one is the best. So Duracell, the ratio was 1.29. So 2.59 hours divided by 2 was 129. Energizer 2.62 hours divided by 149. I was 175, and Razorback is 2.39 hours divided by $1.48, which turns out to be 1.61. So as you can see in the bottom of this chart, 1.75 is the biggest ratio, ending at 1.29. If we put that into consideration, Energizer is the best brand of batteries out of the 3, giving you the best performance for the price. Even though Duracell at times was a little bit better performer, it's a lot more expensive compared to the other 2. So in terms of what you're paying for and what you're getting out of it, Energizer will be your best bet. So in conclusion, as I mentioned already, the best battery for you and the best value that you're going to get is Energizer out of the batteries I tested. And as I also mentioned before, even though I've noticed that the batteries also get hot and can also deteriorate the performance of the battery, as well as another thing to keep in mind is to make sure mixing them, and maybe try different batteries or change out the camera to see if that has any correlation or any issues. But out of the testings that I did, that's what the answers that I could come up with. If you have any questions, don't hesitate to contact me.